Semicircle gamma has diameter AB of length 14. Circle capital omega lies tangent to AB at a point P and intersects the semicircle at points Q and R. If QR equals 3 root 3 and angle QPR is equal to 60, then the area of triangle PQR equals A root B over C, where A and C are relatively prime positive integers and B is not divisible by the square of any prime. What is the value of A plus B plus C? So you have to first draw our semicircle with diameter AB of length 14. That's this one. The endpoints are A and B, and AB is equal to 14. And now we have a circle which lies tangent to AB at a point P, and it intersects the semicircle at points Q and R. This is point P, and the points where it intersects the semicircle are equal to Q and R. We assume that QR is equal to 3 root 3, and angle QPR is equal to 60, and we have to find the area of triangle PQR. So first, we notice that we're given the length QR and the angle opposite side QR. So that makes for good use of the extended law of sines. The extended law of sines says that A over sine A equals 2R, where R is the radius of the circumcircle of the triangle, and little a denotes the side opposite angle A. So in this case, QR over the sine of angle QPR is equal to 2 times the radius of the circumcircle of triangle PQR. But we know QR is equal to 3 root 3, and the sine of angle QPR is the sine of 60, which is root 3 over 2. And that's 2 times the radius of the circumcircle of triangle PQR. So this is just 6 equals 2 times that radius. So the radius equals 3. So that's good to know that the radius is equal to 3. And we also know that the larger circle's radius is equal to 7. I'll call the centers of the circles C and D. So now you notice that since the circles both pass through Q and R, it follows that their centers both lie on the perpendicular bisector of QR. So line CD is actually the perpendicular bisector of QR, which meets QR at its midpoint M. And this angle is a right angle here. So we can remove the 3 root 3, call this M, and write 3 root 3 over 2 on either side of M. And now, since we know the radii of both circles, we can use the Pythagorean theorem on triangles CMR and DMR to find CM and DM, respectively. So we have that CM is equal to the square root of this length, which is just the radius of the semicircle, which is 7, squared, minus MR squared, which is 3 root 3 over 2 squared. And that's equal to the square root of 49 minus 27 over 4, which is the square root of 169 over 4, and that's equal to 13 over 2. Now dm, if you see here, that's equal to the square root of dr squared, which is just 3 squared, minus 3 root 3 over 2 squared. And that's equal to the square root of 9 minus 27 over 4, which is equal to the square root of 9 over 4, and that's equal to 3 over 2. So we have CM equals 13 over 2 and DM equals 3 over 2. And based on this, we can find CD equals 13 over 2 minus 3 over 2, which is just 5. We have angle DPC is a right angle because the angle formed by the center of a circle, the point of tangency, and the tangent line is always a right angle. So that must be a right angle, and CP is equal to 4. So now we have everything we need to assign coordinates to the picture. We can let C be the origin. Then we have to find the equations of the two circles. So the first one is just x squared plus y squared equals 49 for the semicircle. X squared plus y squared equals 49 because it's centered at the origin and has radius 7. The other one is centered at the point 4, 3 and has a radius of 3. So we can write x minus 4 squared plus y minus 3 squared equals 9. So we can manipulate these two circle equations because points Q and R lie on both of the circles, so they have to satisfy both equations. So after we're done manipulating, we can find the equation of line QR. And then we can set up the point line distance formula to find the distance from P to QR, and then multiply that by QR over 2 to find the area of triangle PQR, and then we're done. So let's get this into simplified form. X minus 4 squared is just x squared minus 8x plus 16. And y minus 3 squared is just y squared minus 6y plus 9. And this is equal to 9. So if we subtract 16 plus 9 from both sides, we get that this is equal to 9 minus 25, or negative 16. And now we're ready to subtract the two equations to get the equation of line QR. And that's the equation of line QR because the points satisfy both of these equations. So we get 8x plus 6y. The x squared and y squared cancel out. So it's just 8x plus 6y equals 49 minus negative 16, which is just 65. Or if you want that in point line distance formula terms, it's 8x plus 6y minus 65 equals 0. And we have to find the distance from P, which is equal to 4, 0, to this line. So that's going to be equal to the modulus of the following quantity. It's just 8 times 4 plus 6 times 0 minus 65 over the square root of 8 squared plus 6 squared. This is the point line distance formula. So we just have this, and that's the distance from P to line QR. It's the length of the perpendicular drop from P to QR. So this is equal to the modulus of 32 minus 65 over 10. And that's equal to the modulus of negative 33 over 10, which is just 33 over 10. And we said that we would multiply this by QR over 2 at the end to find the area of triangle PQR. So let's do that. In the end, the area of triangle PQR is equal to 33 over 10 times QR over 2, which is 3 root 3 over 2. And that's equal to 99 root 3 over 20. This is in the form we want it to be in. So A plus B plus C is 99 plus 3 plus 20. And that's equal to D, 122. So thank you all for watching my YouTube video. I hope you enjoyed. Good luck on the AMC 12A, which is in 5 days on Wednesday, November 8. And please follow my channel if you would like to see more videos. And help us to get to 200 followers by Tuesday, November 14, the AMC 12B. And 400 followers by the Amy 1 on Wednesday, January 31.